Let's get started. I'm going to talk about IoC container, but first some technical stuff. You can talk about this with the hashtag DPC and tag me with the ridiculously long Twitter handle, if you can get that before I skip this slide. So hi, my name is Hannes. I can describe myself with a couple of emoji characters. I'm in Belgium. I like to swim, cycle, and run. I don't do triathlons. I just like tree sports. That's it. So let's skip my introduction. Let's talk about IoC container, because IoC container stands for International Olympic Committee. That's a joke. It also doesn't stand for containers with Docker and stuff. Just IoC container stands for inversion of control. Inversion of control is a design patterns. So we're gonna talk about a couple of design patterns first, because we need to get things a little bit sorted out. We all know solid design principles and stuff, but it doesn't hurt to go over them just one more time. So there's a bit of code here, and there's basically a service class which uses some FTP connection and then retrieves a file and does stuff with it, calculates a result, and then returns the result. But this class works in itself. It's fine. The client is happy, the customer is happy. But it doesn't know anything about the rest of the application. It just works in itself. We can create an index.php file, create a new service, and then do calculate. That's fine. It doesn't need to work in a framework. It's fine. But requirements change. The customer can come in and say, well, we need to change this and that and then that. And then we're kind of stuck here. We might have to enter more code here, and this file can get ridiculously long. So to change this, we need to refactor this step by step. I'm going to explain the steps and explain what design patterns we actually use. So we see a constructor which calls an init function, which does some magic to set up the class, right? A better way to do this would be to use a service container. The service container would be capable of newing up this application, this service class, and do everything it needs to, which was going into the init function first, but then inject all of that stuff and make sure that the service class works with the calculate, so that the calculate method works without having to do everything of the setup stuff inside the service class. So that is inversion of control. Instead of the service class doing all of the stuff to set it up, the container will do this. The container will create everything that's needed to make this service class work. So some design patterns first. So the first thing we're going to change is the init function, right? Instead of newing up the FTP connection in this service class with all of the connection stuff and all of the host parameters and the authorization, we're going to inject an FTP connection here. This is the first design pattern, dependency injection. So the service class depends on FTP, an FTP connection. So instead of newing up this connection here, we're going to inject it. Dependency injection. Right here, we're going to use constructor injection. That's a form of dependency injection. So that's the first one. But then the client comes in, or the customer, or whatever actor in the company comes in and says, well, we are hitting this FTP server a lot every time we do this calculation, so we might cache this FTP file locally and prevent from hitting the FTP server over and over again. So naturally, this gets assigned to some developer, and the developer says, oh, well, this is where the FTP connection is happening. This is where we get the file. This is where we add the caching, right? This is like locally, we just add 2 lines here and we're done. But then the customer comes in and says, well, I need to know how many times we are actually hitting this file. So naturally, the same developer gets assigned, and the developer says, okay, I've done this before. I just add 2 lines here, and then we're done. It works. It's a permanent fix. And that tends to become a, wait, someone said it in a different talk. It's a temporary fix that becomes a permanent fix, right? So we're just adding more code where the other code was. And it works, it's fine. But then we see this FTP thing happening over and over again. we're still tied into FTP. And a lot of stuff is happening in this class. What this class is supposed to do is do a calculation on the content of a file. The original purpose of this class was not to do the caching or not to do the logging, right? So this single responsibility principle, which is part of the solid, the first letter is S, so single responsibility, is clearly violated here. So we're just going to take the blob of code, so everything with FTP, and we're going to move that into a different class. So what's remaining in the service class is only do the calculation and return the result. So everything that has to do with FTP storage or retrieving of the file, we're just going to move that into one new file, one new class. This is a single step in a refactor. So we're going to create a new class, FTP storage, which depends on the FTP again, right? And then we're going to create a new method called get file name, and it will return the file content. And it's going to do the exact same things. Get the file, cache it, log it, return the result, return the content. So naturally, we're also refactoring the service class, and it's going to take only this FTP storage, which is a low-level implementation, but slightly more high level than the FTP, right? We're going to get the content of the file, do some calculations, and return the result. This is a pretty good class. This is pretty good refactoring. But the next step is, customer comes in and says, well, this FTP server, we're going to shut it down. We're going to move all the files to a different server, or a different storage class, or a different storage method. Could be S3, could be just HTTP, could be Git, whatever. So this FTP storage was not high level enough. We're going to create one level higher. So instead of having an FTP storage, we're going to create one more abstraction on top of that. And that is called the storage layer. I'm just inventing this, but in real life, I would use Fly System for this, because that's a better abstraction than creating your own interface. But for the purpose of demoing some design patterns, I'm creating my own interface here. So interface storage has exactly the same interface as this FTP storage. It has the same one method, public function get, file name returns content. So a super simple refactor here for the FTP storage. We're just going to add implement storage. That's the only two words we have to add here. And then for the service class, we're going to replace public function construct FTP storage to public function construct storage. Just a little bit more high level. And then what we enabled with that, we changed four words in our application. But by doing this, we enabled a lot of new stuff here, just by adding one more layer of abstraction. We can, for example, create a cache decorator, which we could wrap around FTP storage, which we could wrap around S3 storage, HTTP storage, Git storage, whatever you want. We're going to enable us to add caching to every single storage implementation. So every single low-level storage implementation can get this caching feature, this caching trait. So this is a wrapper, and it takes a wrapped storage class, another low-level implementation of storage. And this implementation it's pretty simple. It's single responsibility. It can cache a retrieved file content. We can do the same thing for logging. We can create a logger decorator, which implements the storage. This is very important, implement storage, because otherwise you cannot wrap the cache decorator and the log decorator at the same time, right? They all need to implement storage, because otherwise you cannot enter the log decorator in a cache decorator. Again, single responsibility. Just log something to a PSR logger, and then get the content from a wrapped storage file. So the FTP storage class can be refactored, and all of these lines that were above this line just can go, and we can use decorators to add these features to this storage object. So previously we had this dependency graph. We had the service which depends on a low level, but it's higher in the graph, which is kind of weird. Depends on the low level FTP storage, which depends on the even lower level FTP class. Instead, we refactored this and we made the dependency graph look like this. The service class depends on a high level storage interface. And we have some low level, super low level FTP storage class, which implements this storage class. So notice that all arrows are pointing upwards, so that's good. Everything depends on a higher level abstraction, or implements a high level abstraction. That's very important in a dependency graph. If your arrows are pointing down, no good. So we have different implementations. We can have the FTP storage, cache decorator, S3 decorator, Git decorator, Git storage, HTTP storage, whatever you want to add here. We can implement whatever we want, and then the service can inject it. Or it can get injected into the service. So this is the comparison between the awkward dependency graph and the correct dependency graph. Now, previously, when we needed a new service class, or when we had to new up a new service class, we would do this. New service, inject a FTP connection. But now we have to do this. We need to create a new service. Wait. Before we can do that, we have to create a new FTP connection first, then create a new FTP storage, then wrap that with a log decorator, then wrap that with a cache decorator. Or we could reverse that. We could first wrap it with the cache decorator and then the log decorator, but then we would have more logging entries. So it's very important which one you wrap first. And then we inject the total storage class, which is the cache decorator, but the service class doesn't care if it's a cache decorator object or a FTP storage object, as long as it's type hinted storage object. We inject that into the service class. That's a lot of code to write to just create a new service class. And this is where the container comes in. The container will know everything about the service class and its dependencies and how to create those dependencies. So the container will know, well, I need this service class object, and the service class object depends on a storage interface object. And okay, this storage class needs to be an FTP storage class wrapped with the log decorator, wrapped with the cache decorator, and then injected into that. And then we need to return the service. So to quickly go over these design patterns, we have dependency inversion, which is inverting the dependency graph. We're going to point upwards instead of do low-level implementations. We're going to point to an interface instead of the FTP storage. And then we're going to add more implementations as we need them. So a lot of people think that this is the DI. There's some confusion about the DI design pattern. There's two of them. There's dependency inversion and dependency injection. So dependency inversion is inverting the dependency graph and pointing to an interface instead of to a low-level implementation. But the dependency injection is injecting something in a constructor, through a constructor or a method. There's two types. So constructor injection and method injection are two types of dependency injection. That's also the DI. That's another DI design pattern. And then there's inversion of control. Inversion of control is basically, instead of the service class newing up everything, let the container do that for you. The container will new up all the required objects, wrap them with other stuff, call some methods in there, do some method injection on those, and then finally create a final object and return that. So let the container, IoC container, help you with creating new objects. It's also sometimes called composition. So wrapping stuff with decorators and injecting that, all of that is called composition. There's a ton of packages out there. There's Symfony, there's Zen, there's AuraDI, there's Pimple. Just go to packages.org, type in container, you'll find a lot of them. But most of them implement something called container interop/container interop or PSR/container. PSR/container is an implementation of PSR, Well, PSR/container is an interface that is defined by PSR11. PSR11 is the PHP fix standard recommendation. It's not a standard, it's a recommendation. But there was this container interop/container interop, which had basically the exact same interface. But they deprecated that in favor of PSR11. It was released on 14th February, so Valentine's Day 2 years ago. That's why the heart. So this was container interop, and they just added extends PSR container, and then that's it. If you upgrade to PSR12, version 1.2 of the container interop, you're basically using PSR container. And the PSR container looks like this. It has two simple methods, get and has. Get returns a initialized object, and has returns a boolean. Can I actually resolve this or not? So let's start using this container, right? How does the container build all these objects? How does the container know what to wrap and when to inject something? Without any configuration, a container could technically resolve an object or resolution, whatever, object resolution or resolving, same thing. Could technically do it automatically by using something like this. The PHP leak container has something called a reflection container. And a reflection container uses PHP's internal reflection API. And the reflection API can allow the container to take a look at the code, to take a look at the constructor, the arguments, the argument type hints, and then that way it can actually see what needs to be injected. So when we ask the container to create a sendInvoice class, it's going to use reflection. It's going to take a look at the sendInvoice class itself. So this is the sendInvoice class, and it has constructor, and the first argument is mailer. It's type hinted mailer, and the name is mailer. So in order to be able to new up a sendInvoice object, it needs to resolve mailer first. So it's going to take a look at mailer. It's going to take a look at the constructor first, and then try to do injection. So it's basically using this line of code. It's going to create new reflection class, get the constructor, get the parameters, loop over those, get the type hints, and then try to use those type hints to recursively create all the dependencies of this sendInvoice class. This feature is built into the Symfony DI container, Zend, Laravel, Leak container. You just name it. Most of them have it. So it's going to use reflection recursively. So if the mailer has some more dependencies, that's going to look for those dependencies and try to resolve those first. If something in the dependency graph is not resolvable, it's going to throw you some exception. But what if our code is solid? What if our service class has a storage interface type hinted argument? Well, you cannot really new up an interface, right? You cannot say new storage, but storage is an interface. It's not possible. So our code is perfect in the solid principle way. So we need to help the container to resolve a new storage object. So we're going to help this container. And this is something that is not standardized by the PSR11. PSR11 is just has and get, that's it. So we're going to help the container to resolve stuff. And there's a couple of situations here. The first situation is an interface is type hinted, but we're going to help the container to say, well, if a storage is needed, create this FTP storage class, wrap it with the cache decorator and stuff. So the first thing we can do is say aliasing. First, we say, well, when something is type hinted mailer interface, we actually get a proper mailer. And this is a low-level implementation, which is an implementation of this mailer interface, right? Something that most containers allow you to do is say, or call this add method. It could be named in different containers. It could be named differently in different containers. But in most containers, it's called container add. And then we're going to give it a name. Could be an interface name, could be a string, could be anything. This is basically a string, right? And then the second parameter is an anonymous function. And this anonymous function, when we call it, or when the container calls it, it should return an object that is interfaced mailer interface. So we can say, this is the most basic implementation, and we're going to use this a lot. We're going to say, well, when a mailer interface is needed, execute this anonymous function, and it will call the container itself again and create a mailer class. This is a lower level implementation of mailer interface. There's some sugar syntax sugar in Symfony and Laravel, which allows you to say, well, when the mailer interface is needed, just create a mailer class. In Symfony, it's called setAlias. In Laravel, it's called alias, because Laravel is always shorter and simpler. Situation 2 is when a class has some constructor arguments which are not type hinted. For example, the first few arguments might be type hinted, but then it has like a host string typed parameter. That's not really resolvable by the container. There's no type hint there, except for a string. The solution is to define dependencies. Again, we can use the same thing here. We can use container add, just create an anonymous function, and this anonymous function will be called by the container. Create a new mailer, inject the username and the password. Or, in Symfony, we can use this. Container register mailer, add argument, first argument, add argument, second argument. So it's going to store those arguments, and when a mailer class is initiated, it's going to use this first argument and the second argument as the constructor arguments to new up this mailer. There's different ways of doing this in different containers, but I'm just giving a general overview here. Situation number 3 is when a class is type hinted, always return the exact same object. What I mean by this is when you want an entity manager or an event dispatcher or a translator, we always want the exact same translator instance because of global state. Our entity manager needs to keep track of all the entities, or the event dispatcher needs, you only need one, right? Just calling the event listeners for a certain event. You just need one. So the first time we resolve this translator or this entity manager, it's going to new it up, only the first time, and then it's going to save the instance, and then the second time when the container is called, it's going to return exactly the same instance. So we're going to share the same instance for different calls to the container. Again, there's different implementations here. The PHP leak container says use the share method. Laravel says use the singleton method. And Symfony says register stuff and then set shared to true, so that whenever it's being resolved again and again, it's going to use the same exact instance. The next situation is when different classes are type hinting the same interface or using the same type hint, we still want to use different objects, different configured objects. We want to configure them differently. So, for example, the photos controller needs a file system object, but it needs to point to the photos folder. And the files controller needs to have a file system interface object, but it needs to point at the files folder, or an S3 folder instead of an FTP folder. But it's type hinted file system interface because that's all it needs, right? So in this case, we're going to use contextual binding. We can, in Laravel, do this. We can write a sentence, container when photos controller needs a file system interface, give it file system.photos. This reads like a sentence. And then we can use container bind file system photos, resolve it. Container bind file system files, resolve it. This way we can add 2 different entries to the container and say, well, when the photos controller needs this file system interface, use file system.photos. And when the files controller needs a file system interface, use file system.files. But again, we can use the add method for everything. We can use container add file system.photos, And when a photos controller is being resolved, use this anonymous function, get the file system.photos first, and inject that into the new photos controller. And we can do the same thing for file system.files. The next situation is when we are resolving something, it needs to do something more than just constructor injection. For example, when we have an entity manager and it's being resolved by the container, but we need to add some model listeners. These are listeners that are listening to certain events on a model or on an entity. So another example is when something is type hinted environment aware, we want to inject the environment name. Could be production, could be staging, could be local. We can implement this with an interface and a simple trait that we can add to any simple class. We can do this using a container by using something called container events. Some containers might call it inflection, other containers call it hooks. Different containers, different implementations, right? But they all do the same thing. In the lead container, it looks like this. It's called an inflector, and we say when an entity manager is being resolved, before returning it, call this anonymous function, pass it the entity manager as the first argument, and then the anonymous function can do whatever it wants to set up this entity manager after it's being resolved and before it's being returned. So after and before, it kind of sounds like a hook system. So this entity manager needs some more configuration. We can get the configuration, add some entity listener resolvers and model listeners on this entity manager. This is all some setup that's being done before it's being passed on to wherever the entity manager is being injected. In Laravel, we could use something like this, container resolving anonymous function, and then the anonymous function will be called with a environment-aware object. So anything that is type-hinted environment-aware will be passed through this function first before being passed on. And then we can call the setEnvironment function on the environment-aware object. Note that we are just passing a function here, and Laravel will look at the first parameter of the function, anonymous function, to look up what type of object this needs. So it's going to use reflection again to take a look at the first argument of this anonymous function to know when to call this. So this feature is pretty useful for quickly injecting some stuff like a command bus or an event dispatcher. We can use interface and trait to add certain features to a photos controller, for example. If the photos controller needs a command bus, we can say implements command bus aware, uses command bus aware. And then when the container is already set up, it will automatically inject a command bus aware when it's resolving a photos controller. The same thing with the event dispatcher or environment aware, whatever. We can also use this to inject soft dependencies. Soft dependencies are dependencies that are needed in this class, but not always. For example, we have a mailer class, and this mailer class can send an email, or it can send an email through a background process or a background worker. So it can queue something or put something on a queue to be processed later. So we can use mail send or mail queue, whatever. But this queue service is not always needed. So when we new up this mailer class, it doesn't already need the queue in the queuing instance or the queuing dependency. So that's a soft dependency. So in order to do this, we can create some kind of resolver. Right? This is an anonymous function, and we can pass it on to the mailer. The mailer has a function, mailer set queue resolver. And this queue resolver takes an anonymous function that will do whatever is needed to create a new queue instance and use that queue instance in case a mail needs to be queued. So in Laravel, this is done like this. We do mailer resolving mailer, container resolving mailer. When the mailer is being resolved, set some kind of anonymous function that will be able to resolve a queue instance. And then the mailer does not depend on the container. It just depends on some random anonymous function. Whatever is in the anonymous function It doesn't matter. It's going to call it. It's going to call this anonymous function. And we're hoping for this anonymous function to return a queue instance. That's all it needs. It doesn't need to depend on the container. It just needs to depend on an anonymous function to resolve a queue instance. Another use case for this is setting configurable variables. For example, you have a validator, and this validator needs to validate some file types, right? You upload a file, and it needs to be an image/JPEG or image.png, whatever, and you want to configure that. You want that in some kind of YAML file or whatever your preferred type of configuration is, but you don't want to inject all of that configuration stuff or framework stuff in your validator. So you're going to create a method called setAllowedFileTypes on the validator. And then whatever container you use, doesn't matter, you're going to call this setAllowedFileTypes on booting up this validator. There's a typo here, it needs to be validator, $validator. Anyway, so whenever this validator of this type is being resolved, we're going to call this method. This is called method injection. We're going to call this method setAllowedFileTypes and inject whatever is needed. Note that the validator does not need any knowledge about the container or the framework's config method or config class or whatever. So this is a way to make your code less framework dependent. So we've seen all of this stuff like aliasing or method injection or stuff like that. Where do we put all this? Where do we put all this code? Is it in a big bootstrap.php file? Nah. In Symfony we can use, or in Symfony framework at least, we can use configuration files or we can use factories. I think there's more methods than this, but I would prefer one of these. Just to put everything of this configuration in a different file, or just to separate it and to make it organized, right? In other frameworks, we can use something like this. Illuminate/container has a service provider. Leak/container has a service provider. So naturally, there's a container/interrupt/service provider, which makes some kind of abstraction of that and makes something. It doesn't really took off, to my knowledge, but there's different tools out there that allow you to put all this in different classes to organize all this stuff. I think we still have 10 minutes, right? So how do you use this container? Well, we've seen the PSR/container interface. It has a get method and a has method, so that's pretty easy. The first one, the has method, returns a boolean. The second one returns an actual initialized object. But there's different ways and different implementations to do some more stuff with this. For example, when we say container get file system, we can add some more parameters here, just to let the container know, well, when you're resolving this, there's some more options. We can say add file system, call this function, and then we can look at the arguments that are being passed here. This arguments array will be passed, and then we can do some more stuff with that. We can do some if-else stuff here. For example, we can pass in for example, a folder name or something. Let's just skip this slide. We can also call functions and let the container see what needs to be injected here. How does this work? For example, we have a anonymous function, this function mailer. It needs to be called. But we just want the container to resolve whatever is needed to call this. So we just do container call, pass this anonymous function, and then it's going to use new reflection function, use the callback, get the parameters, loop over those parameters, to take a look at all the type hints, resolve those type hints, and then eventually call this anonymous function. So that's a pretty neat feature. And then in Laravel, we can do container wrap, and then say listener handle, and that that will return a wrapped anonymous function, which call the container in itself to resolve all those dependencies that are in listener at handle, and then that will be called. This is the actual implementation of this wrap method. It's going to wrap the anonymous function, or the calling of this anonymous function, in an anonymous function without any parameters. So this is pretty useful for, I find this pretty useful in legacy applications where you still want to use a container, but the legacy application needs to call an anonymous function without any parameters. So when you still want to inject stuff in there, we can wrap stuff, or we can wrap a callback to be able to use the container in a legacy application. And then one last feature I want to talk about is tagging. Note that tagging in Symfony and Laravel are not the same. I'm just going to talk about tagging in Laravel. I think in Symfony it doesn't have any useful meaning other than just organizing stuff. But in Laravel we can tag different container keys, or the keys that we use to resolve stuff. So we can say, well, when filesystem.images is being resolved, we're going to tag that file system, or filesystem.pdfs. We're going to tag that file. We're going to tag that as a file system item. So we can ask the container to resolve all things that are tagged file system at the same time. So we can loop over all file system tagged items, resolve them from the container one by one, loop over them, and then do something with them. I have yet to find any useful use cases for this, but I think it's a pretty neat feature. So yeah, using a container. Note that I try to avoid injecting a container as much as possible, because that is basically injecting your framework in your own code. You want to avoid that. The only place where I would use a container is when you don't know what to inject up front. For example, in a factory, you don't know what is going to be resolved, or what you have to do, what you have to do up front. Or for an event dispatcher, you don't know what listener you're going to be calling later on, or what event will be dispatched. Or a router, you don't know up front which photos controller or files controller that you will have to resolve. Same thing for a command bus. It's like the event dispatcher. You don't know up front what command will be called. So I would only use the container in these cases where you don't know up front what you will have to resolve. Some bonus slides because we still have 5 minutes. Solving circular dependencies, right? For example, you have a queuer and a mailer, and the queuer depends on the mailer, and the mailer depends on the queuer. That's a pretty circular dependency. That's pretty hard to resolve for the container, because the container will try to resolve the mailer, and then try to resolve the queuer, and then the mailer again, and then the queuer again. So it's going to be stuck in a loop, and most containers have some kind of mechanism to detect this, but you might run into some kind of PHP weird error. But to be able to resolve this, we're going to create one soft dependency and one hard dependency. For example, we're going to adjust the mailer to have a soft dependency so that the mailer can be resolved without the queuer to be resolved. So when we new up a new mailer, we can just inject a callable in there with setQueueResolver, and then when the mailer is needed, it can eventually when the queuer is needed, it can actually call this a callable, and then the queuer will be resolved. So this is basically breaking up a circular dependency by making one of the two dependencies into a soft dependency. So yeah, this is what it looks like. Another thing that a lot of people ask me is, how would you inject different stuff in a different environment? And this is how I would do it. So in the service class, I would have container bind or container add filesystem.photos, and then I would check the environment variable and then inject different stuff, or new up different stuff if needed. For example, I would use a normal S3 connection in production, but when I'm doing some kind of integration test or some kind of API test, I would use some memory adapter. And this is where I would do this. Inside the anonymous function that resolved the file system.photos, I would swap them out based on the environment. All right, so to quickly recap my presentation here, we talked about reflection, using the reflection API of PHP to automatically detect which type-hinted objects to inject. Then I talked about aliasing, soft dependencies, using the container, all that stuff. I hope you learned at least one thing today. Thank you.